Okay, I think it's time to get started. Can you hear me? Well, not too loud, I hope. Fine. Yeah, welcome this afternoon. There are just 2 sessions between you and the Stammtisch, and I hope we can make it interesting up to then. So my name is Alexander Nyssen. I work for Itemis in Lünen, which is normally 4 hours to the north. We took a bit more yesterday, but it's not far from here, if you took a look from a broad scale. I'm here to talk about the Graphical Editing Framework. I'm a committer on GEF for a couple of years. I've taken over project lead also some years ago. And I want to talk about the next generation of the Graphical Editing Framework at Eclipse. Most people know the Graphical Editing Framework, but they usually got in contact with GEF 3.x. So who of you has used GEF 3 already? Yeah, quite a lot. Even if you haven't used it directly, you probably have used it indirectly because it's the base technology for GMF and graffiti. So used in lots of modeling tools and also directly used a lot. It's based on SWT, and it's basically providing framework components to build up graphical views and editors for the Eclipse Workbench UI. It was initially contributed by IBM in 2002. That's really something you need to consider. That's the time when Windows 95, I think, was still out. And the last component, Zest, which is for graph visualization, was added in 2007, originating from University of Victoria in Canada. I don't want to talk about GEF 3 today. I just want to mention that we have put it in maintenance mode because we have a new code base around, and all those who might get disturbed as GEF 3 dropping out of the SimRail train, we will keep it there because pretty much a pretty lot still depends on it, so we can't simply remove it and replace it with a new. So we have ensured that you can take the new one and the old one and install them in parallel, so they won't hurt each other. Today I want to talk about GEF 4, which is the new code base, and there's already one difference in that we now provide 2 small end-user tools. One just happened to join our project. The other one is a kind of reference implementation for our whole framework stack. So that's something we internally use very much to test our abstractions and our implementations. And it has a new scope. That means we are not only targeting Eclipse integrated graphical applications, but we're also able to run standalone rich client applications. We are no longer rely on SWT, but we stick to JavaFX rendering technology, which is a couple of years younger. And we have graduated this year, so the Neon release was the first release where we included a graduated version of GEF 4. All components got the version 1.0. The complete release has version 4.0. Just that you don't mix things up there. And we shipped another bug fix release a couple of weeks ago with Neon.1, where we basically did some performance and memory fixes and cleaned up a bit in detail. So the next generation has finally, because we are working on GEF 4 already for a couple of years now, has finally taken over. And we want to emphasize that by also changing names now when going to Neon. So the GEF project was basically named according to the old components that we had. And the overall release versioning that we used for Mars and for earlier releases was basically motivated by the versions of the original product components. So the Mars release was a 3.10 release, and it shipped GEF 3.10. We already included early snapshots releases of GEF 4 in that code base, but we graduated with Neon this year, and therefore we used 4.0 to refer to the Neon release, and that is why this title of the talk came up with .o.o. We are now transferring the code base, so we used a GEF4 prefix in all our bundles up to the Neon release, and we are actually replacing that, and we are using the GEF name, the original project name, to refer to this new code base beginning with the Oxygen release. So you will have GEF4 1.0 components will be transformed into GEF 5.0 components. And in the same time, we will put the old GEF code base and refer to it as GEF legacy from now on to depict that something new is around and people should rather look at the new one than the old. We also emphasized this by having moved our code base to the GitHub, and we have two separate repos there. So the GEF4 code base is located in the GEF repo now, whereas the old code base is hosted in the GEF legacy code base there. We still produce builds for both of them. We ship both as part of the simultaneous release, and we have that clear distinctions now that this is the new production code base and this is the old production code base, which is still maintained. So if you want to contribute patches, if you are concerned with bugs, you can contact us, but we are not actively developing it further. Instead, we're concentrating on the new code base, which I want to show you today. And as I said, it includes 2 end-user tools and basically 9 framework components, if we summarize them as well, because they have framework aspects. And these end-user tools, the one, Claudio, you can use to render word clouds, to export them as images or embed them in an SWT UI. We have a word cloud renderer included. And we have some .authoring environment, which is constituted of an Xtext editor and a graphical viewer, and also some .based image and PDF export that you can use and can trigger from your UI. The other components basically form 2 framework stacks. So we have a framework stack that basically can be used to build up arbitrary graphical editors and viewers, where you can take an arbitrary model to visualize. So GEF is not dependent on EMF or any other model technology. You can visualize Java POJOs or data from a database or whatever. The second stack adds a default model. So we have some graph model that you can use. You can easily build such a model from your actual application model, and you can use that to render. We have some layout algorithms that are included, and we have a component that uses this stack and combines that with a graph model and automatic layouting into what we call Zest. So that component is still preserved, but this new Zest has been developed completely from scratch. So if you know the old Zest 1.x, that's a completely different thing than this new one. Let me show the 2 end-user tools first. So we have Claudio, just a quick screenshot. I will switch to Eclipse now. And this is the .authoring environment. I'm going to show that to you live. So we have that tech cloud view for Claudio, where you can simply load simple text files that contain words, and you can work with various parameters to tweak how these word clouds are rendered. You can change the algorithms behind, you can change how things are aligned, you can toggle with the colors, you can even add background mask and thing, and you can export that to an image file. So that is basically a neat and small component that has been contributed to the project some years ago and which we still preserve. It's completely based on SWT, so it basically renders these words on an SWT canvas, and it's the single component of GEF, of the new GEF, that has not been migrated to Graphviz yet. The other thing is the dot authoring environment that I already mentioned, and that basically consists of a xtext-based dot editor. So we have an xtext editor that can parse dot files, and that can validate and provide proposal support. It's yet limited, but we are working on bringing it to a full dot authoring environment. And it can be used to edit Graphviz dot files. I have not asked up front, who doesn't know about Graphviz? Everybody seems to. Okay, then it's good. So these dot files are the input files for Graphviz, and Graphviz can lay out a graph that is described in such a manner. And with this dot editor, I can edit these dot files a bit more handsomely than doing that in a usual editor without validation or syntax highlighting support, or without validation and auto-completion support. We have also added a viewer, and this viewer reuses the complete stack, and you can see that this layout in here is not very nice. That is because dot has a couple of layouts which are quite enhanced, and the GEF4 layout component only provides a couple of very basic layouts. And so using our layout components to emulate such a dot layout, you can see that it's emulated here, does not yield very nice results on each dot file. There are other dot files that produce better input, but especially this one is quite enhanced. And what we have done with Neon is that we have added support for integrating a dot executable. So if you have a dot binary executable there, then it can be used for layouting. I don't know why it doesn't show that automatically. Let's reopen the graph. Let's use another installation. Hello? That's the usual. Oh. You know, that worked the whole day. And that now doesn't. So I restarted and then I can show it to you. So what we basically do there is we render dot input based on the dot executable. So the dot executable actually provides us with layout information, and then we can render this with some proper dot output. Let's see if it works now. Now I can see something, and let me specify the executable path. So now I can see that things are now layouted a bit more enhanced. And you can see that this will allow us to add some interaction capabilities. If we have not integrated that yet, but that is something we're planning for Oxygen, that if I select, for instance, a node here, I could think of a selection synchronization, so I can directly interact with that stuff and use it. And I could usually also think of use cases where such natively layouted things can be easily integrated in an Eclipse view to show some information based on dot. What we've also done is we have integrated an export. So this one is a PDF image rendered directly with dot, and you can see it's pretty close. Yeah, so this is rendered by a dot binary, and this is rendered using JavaFX and our framework stack. So not a huge difference. There are small differences, and we are working on them, but we're pretty far away. So this thing is important for us not only because we can use it to edit dot files and we can show how to integrate dot layout in graphical applications, but also because it reuses the framework components that we have. What we've done for Neon already is that we have integrated this native layout I already talked about. We have added some rendering capabilities that weren't there in the mass version, so you can render different spline types and different label types and different decorations. We have one large thing we want to add in the Oxygen stream, and that is we do not support the complete dot grammar yet. Dot has the capability that labels of nodes can be described by HTML style labels, and we don't support that yet. And we want to add that in Oxygen. And in both cases, so for these HTML-like labels and for subgraphs, we are lacking the rendering support in our viewer, and we want to close that gap as well. And enriching the editor with further validation capabilities and proposals so we can come up with a complete dot or Graphviz dot authoring environment in the Oxygen context. Yeah, for the other framework components, we have quite a bunch of undeployed examples. If you check out the code base, you can simply run them as Java applications and you can play around with things. So we have demonstrations for our geometry APIs, for the abstractions that we built on top of JavaFX, for connections and for anchors and routing. We have demonstrators for the different built-in layout algorithms and also for integrating dots as a layout engine. And we have support for our examples that show how to integrate JavaFX with SWT. To demonstrate these complete framework stacks that we have two deployed examples, and I want to show them to you today. The one basically shows our core stack, so it shows the usage of the common infrastructure that we provide. That basically provides support of it provides an enhanced adapter or adaptable pattern like the one that is used in the Eclipse platform. And we have combined that with dependency injection, with juice-based injection, and that allows us to pretty much configure the whole graphical application based on juice and based on that adapter pattern, and we can reconfigure it as runtime if we want to. So that's a quite flexible approach there, and that's provided here and is used in the above components. Then we have our own geometry API. We provide some additional capabilities in there that is quite usable in the context of a graphical application. So we have abstractions like a curved polygon where you can describe a polygon based on Bezier curve outline segments. We have capabilities to compute intersections of arbitrary shapes. So pretty much everything there that is needed in a graphical application where, for instance, you want to compute precise locations where a connection enters a shape or something like that. We have some extractions on top of JavaFX, and that is bundled in the FX component. So for instance, we have a connection abstraction, or we have some visual anchor concept that is not part of JavaFX, but that is quite useful if you want to have some sort of diagram-like editor or application. Yeah, so where you want to describe something as a connection between two things, and it can be routed, and it can enter a node at a certain endpoint, and it can have decorations and can be clipped at these decorations and so forth. We also have some additions to the JavaFX SWT integration, and that allows us to render our whole application with JavaFX while being integrated in an SWT canvas. So you can use GEF4 inside Eclipse through this JavaFX SWT integration. And then we have a model view controller framework that builds on top of that, and that allows to build up graphical editors and views quite easily. And we have one bundled example, namely our logo example, that you can use to see that whole framework stack in action and to look into the implementation if you need to get a start. And let me show that to you. So the first thing that I should note is that this one is rendered with JavaFX, like the .graph view we have seen already, and it's integrated into an SWT-based workbench. You can directly see it's JavaFX because it looks nicer. Yeah, so you have shadows in here, you have lightning effects, you have all sort of things that you would expect from modern rendering technology. All that comes for free while we use JavaFX. What we provide, for instance, is some infinite canvas abstraction. So if you are used to old-style GEF editors, then it feels a little bit different if you move something to the top left corner, because there the coordinate system was limited, and we have worked on that and come up with something unlimited, at least logically. We have add-in support for gestures, so you can pan around here using gestures. You see I don't have a mouse attached here. I can also zoom using pinch spread gestures, and I can rotate and stuff. So it's all in there. The most important difference for me is that we, in GEF4 and in the model view controller component, we deal with what we call live feedback. So if you know old style GEF editors, then if you drag some node around, then you see some sort of XOR feedback, and if you drop it, then all connections are relayouted and you see what happened. And in this new code base, you can directly see what's the resulting state of your application. So at each point in time when I let loose here, I get the state that that is resulting from my interaction. We also added support for working with curved connections, so you can easily work with Bezier splines in here. I can even disconnect connections. That is something that the abstraction of the old code base did not cover. We have integrated a palette that's new for Neon, because users often ask us, how do we code a palette? And we came up with this more slim approach, so not the classical, you select a tool, and then you click into some palette entry, and then you click on a canvas, but here you directly see what happens, and you just click through, and you can directly move the things around. You can, for instance, rotate stuff. You can apply all sort of transforms on your nodes. And just to mention that, these shapes here are no images, so they're actually rendered based on our geometry API. And therefore you can also tweak their shapes if you want to, so something like bending is possible. What we have added for Neon as well is that we have support now for orthogonal connection routing, so you can see if you have a curved connection, then you have these circle handles you can work with. And you can, for instance, snap handles on top of others to remove segments, or use new handles to create new segments. We have a different approach for these orthogonally routed connections, so you can use certain segment handles, and you have some mid-segment handles that you can use to introduce new segments. And we also snap segments like we snapped waypoints before, so that allows you to select a completely different handling of your connections, or whether you want to use orthogonal or other kind of routing there. Yeah, we have integrations in the for integrating JavaFX concepts with property sheets. So you can, for instance, specify things like gradients using our own controls, and so basically everything you need to come up with a basic application, also integrated in Eclipse. A concept that's also new is that we have introduced hover handles, so that allow a more direct interaction as well. So here, for instance, I can start a connection beginning with a node, and I can directly drag it and connect it. We also have support for deletion handles, and of course everything is undoable. So it completely integrates with the Eclipse workbench, or with the Eclipse operation history here to be more detailed. And that basically is a replacement for the old logic example, in the sense that we try to use all the concepts that we currently support within that logo example. So for instance, that besides using the palette, you can also use the context menu to create new shapes. And so some things are complementary in here just to show how different things can be done. Okay, so that is the first stack that we have. And the basic thing that we want to improve for Oxygen is the API. So you might have noticed that on earlier slides, I made a difference between a model view controller component and its JavaFX specialization. So we had some model view controller and some model view controller JavaFX specific component. So we had some core components and we had the JavaFX specific adaptation of them. And that doesn't really make sense. It makes things too complicated, and we are merging that now for Oxygen. Actually, we've already done it, and the Oxygen M3 milestone that occurs next Monday will have a reworked API there. And we also add some snapping support to that, so you can snap to geometries, so you get indication feedback when you position a node next to another node, or also for orthogonal connections when you position a segment next to another segment or a node. So that will be added for Oxygen. The second framework stack is this one where Zest is on top. And therefore we have basically created the Zest graph example, and it simply shows how graphical layout can be integrated into an MVZ-based application. So you can see I have some specific layout algorithm in here. It's not a very stable layout algorithm. Thus, when I resize the canvas, you see it's not stable and it shifts around. But that's a property of the layout algorithm. Yeah. What we've also demonstrated in this example is that we can do something like semantic zooming. So if you zoom in, then you can see that the nested detail is just made visible at a certain zoom level. And I can also step in completely at the next level. And if I zoom out, of course, I'm one level higher as well. So that adds a bit to this metaphor of having live feedback and being able to pretty much interact with a graphical application without having to go through context changes. So I don't need a context menu to navigate. I can also do that, of course, with double click, but zooming in may feel more natural than just double clicking, because I can then simply see where I'm going, where I'm navigating. So that's just a very simple example. We will enhance that as well to show more of the capabilities that we have, but it's a very nice demonstrating example that shows how automatic layouting can be integrated into a MVZ-based application. We also have a not deployed example where you can look how a Graphviz-based native layouter can be integrated in such an application. So that's not included here yet, but that's something that you can also take a look at. Yeah, I'm running out of time, so let me finish. What we're doing there for Oxygen is that we want to add support for having the layout being computed in the background. So up to now, the layout is always running in the UI thread, which is not a very good idea if you integrate it with some native executable, because you don't want to wait in the UI thread for that. And so we are adapting Zest so we can make that possible, and it will most certainly be something that is not very impacting on the API, but it will be possible to do that mostly under the hood. So if you want to use the framework, then it won't make a big difference, but we think that performance will be improving quite significantly there. Yeah, last slide. So what are the major things, besides what I've already talked about, that we want to investigate for oxygen? This image should indicate we want to make it even better and even easier to use. And that's also the main reason why we now revise a part of that API, because we simply want to make it easier usable there. So this API revision in the model view controller framework, I have committed that for M3, and I think we have the same functionality with 6,000 lines of code less. So removing that abstraction and concentrating on JavaFX completely seems to be a good decision there. I've also worked on Java 9 compatibility quite a lot. You might have heard about Project 6, Jigsaw, and the problems of not being able to access JDK internal API. A lot of the things, the tweaks that we had in our JavaFX SWT integration, for instance, the support for forwarding gestures to JavaFX if you're embedded in SWT, is something that was relying on JDK internals. And we had to basically contribute that all to JavaFX 9, so things are available there, because our workarounds would no longer work. So I've contributed them to JavaFX, OpenJFX, and so we limit our tweaks just to Java 8, and if you use then Java 9, you will get the workaround, or you will no longer lead the workarounds. We want to enhance dot, as I've already indicated, and one thing where we are working on as well is we want to bundle Graphviz executable directly. We have a CQ out there. Nominally, Graphviz is EPL, but unfortunately it contains some GPL code, and we have to get rid of that before we are able to bundle it. So up to now, you only have this preference where you can specify a Graphviz that you have installed. In the future, we hope we can directly bundle it with GEF, and therefore also make it available to other Eclipse components. Yeah, and we want to enhance our MVZ, as already said, with some snap-to support, Zest with some background layout, and this graph model that we provide with some JSON-based persistence, so you can easily persist such a model and can use the model there to build simple editors that allow you to save diagrams and reload them. That's basically all. I think we have 2 minutes left for questions, right? Yeah?
Would this be ready now to replace the legacy GEF under things like graffiti?
I think the question was, maybe you haven't heard it, whether things are mature enough to replace the GEF legacy in the upper stack frameworks like Graffiti or GMF. Yeah, I think so. So we gradiated it, and from my point of view, this API should be used rather than the old one. I think for Graffiti it may be easier, or even for Sirius, than for GMF, because GMF has a white box approach, and they can't easily hide away the GEF details. So I don't think that it makes sense to port GMF, but Graffiti and maybe even Sirius, I think, could be ported to this new API. Yeah?
Playing GEF editors, is there any recommendation how to start, which one to start? I don't know, think around different kinds of editors.
Yeah, we also craft quite a few editors recently based on pure GEF. I think the logo example is a good place to start, usually if you have some kind of diagram-based approach, but maybe we can talk afterwards if you need some detailed guidance on how to start there. I will be here 3 days, and you can come to the Itemist booth, and you'll find me probably or somewhere else. Yeah. Yes?
Are you talking or considering integration with the ELK project, the layout?
Yes, we were in communication, and we have deferred that because they are just reworking their API. We have a kind of overlap because ELK, the Eclipse layout kernel, has certain own layout algorithms, and they integrate dot as well. So they also have a dot parser and serializer, and we have a couple of own layout algorithms as well, and we also have an input model that is quite similar to theirs. So our goal is to get that together, and I think that ELK will have to provide a GEF integration because they are the incubation component, but we will try to support that, and I am in communication with them, and we want to revive that after they have revised their API and we can integrate that. But already now, if you need to integrate dot, you can do that based on GEF alone. You don't need ELK. You can use ELK if you need special layout algorithms, though. Yeah?
There are pretty much use cases where hypergraphs are the underlying structure, where you see that right now graph structures are integrated. My question is there any plan to integrate hypergraphs instead of graphs into the core system?
The question was whether it makes sense to integrate hypergraphs or whether there are any plans to integrate hypergraphs instead of graphs. Actually, the MVZ component, the abstractions there are pretty much capable of dealing with hypergraphs. Just the zest stack, it uses a simple graph model that does not have these capabilities. So you can already do that, but you have to go for the MVZ stack and not for the zest stack, and use your own graph abstraction model to do that. But the abstractions in MVZ, there is no special abstraction for a connection basically in the framework. That's all done on different abstraction, and it's much more capable to represent such kind of structures than the old GEF was. I think we're done. So thank you.